Few things that we need to answer are: number one, we said joint equation of hyperbola differs by constant with respect to h and hc, and the difference is same between them. That is what we have said. We have not discussed that why it happens. Number two, characterization of conics. If degree 2 equation is given to you, how do you quickly identify what conic it is? That is what this characterization is. Third, method to solve general conic, out of which parabola I think we have done for that exam. Parabola we have solved it. But then ellipse and hyperbola, how are we going to solve quickly if it is in general position, degree 2 equation? Okay. So we have to discuss these points today. So I will begin with ax square plus by square plus 2hxy plus 2gx plus 2fy plus c is equal to 0. This is the general equation which is given to you. Okay. Now, we have got two transformations with us. To rectify this general equation, we have rotation and translation. Okay, so these are the two transformations which we can use and get these equations in standard form. Okay, now xy is because of rotation, and x comma y is because of translation. Okay, x comma y is because of translation, because obviously you know when you try to complete the square you have x plus constant bracket square and y plus constant bracket square, and therefore that generates that middle term after squaring which gives us x and y. That is because of translation. So if we shift origin by keeping the axis parallel to x-axis and y-axis, we can always get rid of x and y, linear idea, linear expressions that you have in general degree 2. And by rotation transformation, you can always get rid of xy coordinate. Okay, a product, I mean x into y term is because of rotation. So first thing that we would like to do is we would like to rotate by using our formula x is equal to x dash cos theta minus y dash sin theta, y is equal to x sin theta plus y cos theta. If we substitute this in the original equation, and equate coefficient of x dash y dash and equate coefficient. So substitute and equate coefficient of x dash y dash to 0 and find theta. Okay, this is easy. Just do it. Put this back into the original equation, simplify and equate the coefficient of x dash y dash to 0 and find the value of theta. So if ax square is substituted by this, then what is the x dash y dash term? It is minus 2a cos theta sin theta. That is by first term, x dash y dash. Correct? Second term will give plus 2b cos theta sin theta. That is contribution of second term, and xy, x into y. So this multiplied by this will give me outside is 2h plus 2h, that is x dash y dash cos square theta minus, so cos square theta minus sin square theta. Correct? Correct, is equal to 0. If we equate this to 0, to gone, everything is gone, and therefore what is remaining? So I will not do trigonometry after this, and that is tan 2 theta 2h upon a minus b or b minus c. This is the condition that you get. So if you could find out theta such that tan 2 theta is equal to 2h upon a minus b, using that theta, if you rotate the coordinate system by keeping the origin at the same point, then your xy term will disappear. That is what we have found out. Now, this morning I was thinking, small question. Suppose I have xy system and I have circle somewhere in general position. And if I rotate x axis and y axis by keeping origin same, so I am saying that this equation has this circle has general equation ax square plus by square plus 2hxy plus 2gx plus 2fy plus c is equal to 0. This is a general equation of this circle before rotation. Now if I rotate this, what will happen to this equation? Will it continue to remain like this, or what will happen? What will happen to this xy term after rotation of circle? If it is a circle originally in general position, after rotation also it will continue to remain circle, and in the first place itself this is going to be 0. H is going to be 0 if it is a circle, then h is equal to 0 in the first place. Does not matter where that circle is. So rotation transformation is not required if it is originally circle. That is what I wanted to bring it to your notice. It is easy for you guys. So if it is circle anyway, h is equal to 0. So we can directly say we are into characterization now. Therefore, first characterization, if the given expression is this general degree 2, let us call it as S is given to us. In S, first check delta. Delta means check whether it is a pair of lines is equal to 0 or not. If 0, POL. If not 0, conic. Okay, so that is your first check. Check delta. Majority of the cases the delta will not be equal to 0 unless somebody designs. So first check. Second check is h is equal to 0 and a is equal to b. Sorry. A and B are not equal to 0 and are equal to each other, and H is equal to 0. This is our 9th standard stuff, circle. Because you can always complete the square and you can shift the origin. Eventually the second step that we are discussing, shift the origin to center, and you can get it in center radius form otherwise also. So first these two things are done now. Now let us say that H is not equal to 0. A is not 0 and B is not 0, is 3. Okay. Now after rotation, after you rotate the coordinate system through angle theta, you will get tan 2 theta is equal to 2h by a minus b. So you should find out what is the value of theta through which you are supposed to rotate your x-axis. And after you do that, because this expression is 0 and that is how you have calculated theta, xy term will be absent, and hence your new equation will look like capital A x dash square plus capital B y dash square. Xy term is absent, therefore 2 capital G x dash plus 2 capital F y dash plus capital C is equal to 0. This is our new expression after rotation. Okay, and suppose if we don't have A not equal to 0 and B not equal to 0, suppose this is the easy case. And in that case, if both of them are not equal to 0, then I can always complete my square. We can take A common out, x dash is there, so plus G by A bracket square. So I have achieved ax dash square, I have achieved 2gx dash, right? But I have done some damage which we will control, plus b into y dash plus f upon b bracket square. So we have managed this, but we have done some damage, plus, or maybe let us do it, is equal to g square upon a square, g square upon a, because one a is getting cancelled, that is unnecessarily added, in LHS, plus f square upon b, unnecessarily added in LHS, minus capital C. This is how your expression will look like. Understood? Now we are discussing the case A not equal to 0 and B not equal to 0. So both of them are not 0, and therefore I have courage to put them in the denominator. Otherwise, I would not have put them in the denominator. Now you can call this RHS as capital K. Therefore, your equation is capital A, I mean it's the same equation. Now you shift the origin, shift of origin to minus G upon, shift the origin to minus G upon A, comma minus F upon B. By doing this, this bracket will become capital X. So we will end up getting A capital X square plus B capital Y square. Now, by shifting the origin, will you disturb the constant or it will continue to remain same? Is a good question to ask. By shifting the origin, will you disturb this constant RHS or it will continue to remain same? You can check and tell me. After shift of origin, we are just calling this bracket capital X and calling this bracket capital Y. That is all about shift of origin. And therefore, RHS constant is not going to change. Okay. Now, we have reduced the given equation to this form provided and b is not equal to 0. ठीक. Now there are cases. What are the cases? Suppose, therefore we can write it in the form capital X square upon k by a plus capital Y square upon k by b is equal to 1. Now if k by a and k by b are greater than 0, ellipse. K by a comma k by b, both of them are less than 0, imaginary ellipse. Because you are talking about summation of two squares equal to -1. So we have not discussed this because it is not in real in front of us. Okay. Now if k by a is positive and k by b is negative, it is hyperbola. And if k by a is negative and k by b is positive, we call it as conjugate hyperbola. Okay. Any other case? Like if k is equal to 0, pure, because it is homogeneous degree 2 equation. Okay. So what is remaining now? We are considering both a and b not equal to 0. In that case, we got all possible ellipses and hyperbola. Anything pending here?
सर k0 असला तर पॉइंट होईल ना?
नहीं का?
सर कारण की 0,0
0,0 असेल म्हणजे इट विल पास थ्रू ओरिजिन.
अच्छा, a and b नेगेटिव्ह असू शकतात.
हा, ए आणि बी असणार ना. ठीक आहे. ओके. नाउ any one of them is 0. Say for example, if a is 0. So if a is 0, what will happen to this equation? You can always complete the bracket of b y dash plus f upon b bracket square. Okay, so those two terms are taken care, and then you have one x dash term which you can consider as plus 2g, or you can throw it to the other side. This is by dash bracket square is equal to minus 2g. You have taken it common inside bracket x dash, and then you have one term in RHS which is f square upon b, so plus f square upon bg, 2bg minus c upon 2bg. Correct? The minus plus
तर सीच्या डिनॉमिनेटर मध्ये बी नसेल आणि
सीच्या डिनॉमिनेटर मध्ये बी नसेल आणि त्यांचे साइन पण जरा मी काहीतरी घोळ मारले. परत एकदा बघूया. मायनस साइन कॉमन काढलाय. एफ स्क्वेअर ला मायनस पाहिजे ना, बिकॉज इट वॉज पॉझिटिव्ह इन RHS. एफ स्क्वेअर upon 2bg plus C upon 2G. This is how it will look. Now we have just rotated, we have not shifted yet. And now if you shift shift origin to f square upon 2bg minus c upon 2g, comma, minus f by b. If you shift your origin to this, then you will get the expression looking like b capital Y square is equal to minus 2g times capital X. This is your parabola. Okay. Now, if A is not equal to 0 and B is equal to 0, then it is vertical parabola. The treatment is going to remain exactly same. So, I will wait here and you may write down and try to digest. Special case, if capital A and capital G both are 0, then what will happen? Then what will happen? Capital A is 0 and G is also 0. Then this is pair of lines, or maybe pair of parallel lines. Depending, C is already present there, right? So C is present. So if A is 0, we are left with by dash square. G is also 0. So plus 2fy dash plus C is equal to 0. So you can always complete square. B times y dash plus f upon b bracket square plus C minus f square by b is equal to 0. You will get this expression. Now this is complete square and this is some constant. Okay. So if this constant is 0, then they are coincident lines. If this constant is a negative number, then it goes to RHS becomes positive, therefore they are parallel lines. And if this constant is a positive number, then they are imaginary lines, imaginary parallel lines. Okay, so if A and G both are 0, then it is again a POL, and real, imaginary or coincident will depend on value of that constant. Now, the thing which I want to bring it to your notice is we have rotated first and shifted origin second. Okay, so if we would have our original equation ax square plus by square plus 2hxy plus 2gx plus 2fy plus c is equal to 0. If our original equation, if we would have shifted the origin first, then you can very quickly, now I need not have to do, you can quickly analyze and say that if we would have shifted the origin first, then this equation would look, it is good to, okay, let me do it. A into x plus g by a bracket square, I have taken care of this, plus b into y plus f by b bracket square plus 2hxy plus c minus g square by a minus f square by b is equal to 0. This is my translation transformation setup being ready. Okay, now I am supposed to substitute capital X is equal to small x plus g by a. That is my translation transformation. X is equal to capital X minus g by a, and therefore what will I get here is a into capital X bracket square plus b into capital Y bracket square. What for y I am supposed to substitute y plus f upon b. Okay, plus now what will happen to 2h into I am supposed to substitute x minus g by a into y minus f by b plus c minus g square by a minus f square by b is equal to 0. Okay. Now you understand what I am trying to do here is I am just shifting the origin to minus g by a minus f by b and trying to look at this expression, and we end up getting a capital X square plus b capital Y square plus 2h capital XY, and then what remains is your constant is equal to 0. Do you understand now? 2h into g by a नहीं. Oh, oh, oh. Okay, and after, because we are shifting the origin to uh, I mean, is this correct whatever I have done? Yes.
तर तिकडं एक्स वाय ची टर्म पण एक्स मतलब म्हणजे मायनस एफ बाय बी इंटू 2h इंटू एक्स ची टर्म असणारच ना परत.
ती नसणार, कारण ते ते करूनच आपण शिफ्ट ऑफ ओरिजिन काढलेलं आहे.
नाही सर, पण आता ते जे एच चे ब्रॅकेट आहेत ते जर ओपन अप केले तर मग एक्स इंटू मायनस एफ बाय बी चे एक प्रोडक्ट असणार ना.
कळलं मला तू काय विचारतोस.
Sir,
Okay, so why is it not matching is because I have not written these two steps in this expression, which I should have written and then substituted for x, capital X and capital Y. Then whatever these terms are getting generated because of this product will get cancelled. So I should have written those, and you will observe that after shift of origin x and y terms will disappear, and hence your eventual equation will look like this. After shift of origin, x comma y terms will disappear. After rotation transformation, xy term will disappear. So now, because we are doing shift of origin first, xy term is surviving and x comma y terms have disappeared. So now if you look at this particular degree 2 equation, then it is almost homogeneous except this k, right? Except this k constant, this is almost homogeneous, and if k is equal to 0, if k is equal to 0, then it is POL passing through origin. It is POL passing through origin, and we called that POL as, okay, if k is equal to 0, then it is POL passing through origin, and we called that POL as asymptote because now you can rearrange, you can rotate and get the conic sections, ellipse, hyperbola in place because of these two. So I mean, it is not fixed that you should always shift the origin first or rotate. You can either way do it. So if we would have shifted the origin, we would have got almost homogeneous equation with constant. If constant exists, then it is ellipse or hyperbola. If constant does not exist, then it is POL. That is what is telling us that it is because of this k you are ending up being hyperbola or ellipse. However, it will be hyperbola if asymptotes are real. If asymptotes are real, then it is hyperbola. If asymptotes are imaginary, then it is ellipse, and that gives us the characterization of this homogeneous part. If 2h square minus 4ab is greater than 0, hyperbola. Because when I equate this k equal to 0, they are going to be asymptotes passing through origin, because they will look exactly like hyperbola with a difference of constant. And that is the why, because if I make a k is equal to 0, it is POL, and it is POL means it is hyperbola, means it is asymptotes, and therefore joint equation of asymptotes differ by constant. This is hyperbola. If k is not equal to 0, it is hyperbola, and if k is equal to 0, it is asymptotes. Therefore, joint equation of asymptotes differ by k. Okay, and this is the characterization: h square minus ab greater than 0, hyperbola, h square minus ab less than 0, ellipse. So that concludes. Now that is why this k is important constant and it does not change. K does not change by shift of origin. K does not change by shift of origin, and therefore even if this k, the constant that you have got after, is going to differ in the original equation exactly by that number. Okay, I am telling you too many things, you need to cross check. The constant after shift of origin is telling us the story about asymptotes. But what we are claiming is the original degree 2 equation, if it is hyperbola, original degree 2 equation, if it is hyperbola, then if you manage this C properly, so maybe ax square plus by square plus 2hxy plus 2gx plus 2fy plus c, this is your equation, and now you add say lambda, another constant to it, so that it becomes POL, then this is your conic up to C, and by whatever constant that you are adding, it becomes asymptotes, and that is why they differ by constant. So we can find out, now this has to be POL. Find what is lambda. For what value of lambda, the general degree 2 equation will become POL. That is the constant by which your hyperbola differs from joint equation of asymptotes, and your corresponding conjugate hyperbola will also differ by that number corresponding to joint equation of asymptotes. That is what is the complete story. I can repeat it if you want to know it again, but try to think and understand what I am trying to do right now. Constant does not change whether it is after shift of origin or before shift of origin. After shift of origin, we visualize that it is joint equation of asymptotes if constant is 0. If constant exists, it is hyperbola. If homogeneous part is a real, can be factorized into real straight lines. So if h square minus ab is greater than 0, it is hyperbola, because they are, that is a real part, you can factorize it. And because constant is not changing after shift of origin, the original equation also will tell us this, the asymptotes will differ by the same constant. So find out lambda for which you want to change the given equation into equation of asymptotes. Now this g by a which I am writing here is a mistake. What you need to do is you shift the origin at say alpha comma beta. Okay, if you want to shift the origin to alpha comma beta, you will substitute the equation capital X plus alpha in place of small x in this equation, capital Y plus beta in place of small y in this equation, and write the entire expanded form, and you will make sure that coefficient of capital X, coefficient of capital Y should be equal to 0. Coefficient. Oh, that is very important step. So you find out, suppose I want to shift the origin to alpha comma beta, what should be alpha comma beta? So that I get rid of xy term. आता बरोबर. In general conic equation, degree 2 equation, we have decided to have alpha comma beta as center of the conic. If it is a center conic with center, then if we shift origin to alpha comma beta, we should get rid of x and y terms. So capital X plus alpha, for small x you will substitute, and for small y you will substitute capital Y plus beta, and make the coefficients of x and y equal to 0. You will get two equations with two unknowns and solve them for alpha comma beta. You will eventually get alpha is equal to hf minus bg upon ab minus h square, comma gh minus af upon ab minus h square. So the moment you have degree 2 equation with you, you find out alpha comma beta, shift the origin to alpha comma beta, and get the equation looking like this: a capital X square plus b capital Y square plus 2h capital X capital Y plus constant is equal to 0. Okay. Now if you have this h square minus ab greater than 0, that means if you get rid of this k by subtracting k from them, you will end up getting joint equation of asymptotes. Okay, you will get joint equation of asymptotes, and therefore now you should do the second activity which I have asked you to do. If you want this to be POL with lambda in it, then what should be the value of lambda if that is to be POL? Lambda comes out to be equal to delta, which is determinant, divided by h square minus ab. So if you add h delta upon h square minus ab to the given degree 2 equation, it becomes POL, and by that constant it differs. Okay, so eventually this k is also going to be, I mean, it is going to be minus of this k. This k is also going to be minus of delta upon h square minus h. Okay, because this k does not change. That is what we have observed. K does not change. It remains same. And therefore, this is your asymptote, joint equation of asymptote, the moment you make it 0. Otherwise, it is hyperbola if h square minus ab is greater than 0. It's ellipse if h square minus ab is less than 0. So I have answered almost all questions. Now let me give you one numerical. If you have understood this theory, find the equation of asymptotes. Find the equation of asymptotes, joint equation of asymptotes of hyperbola number 1. 8x square plus 10xy minus 3y square minus 2x plus 4y is equal to 2. Find the joint equation of asymptotes. Okay, if you want to find out the discriminant, I mean determinant of this POL or this degree 2 equation, A is 8, B is minus 3, C is minus 2, f is 2, g is -1, h is 5. If you evaluate this, you get delta is equal to 49. If you evaluate h square minus ab, you get 49, and therefore delta upon h square minus ab is 1. So from the equation of hyperbola, if you add 1, you get equation of joint equation of asymptotes. That is what this is. 8x square plus 10xy minus 3y square minus 2x plus 4y minus 1 is equal to 0. And to the other side, if you again add this constant 1 to equation of asymptotes, then you will get equation of conjugate hyperbola, which is going to be 8x square plus 10xy minus 3y square minus 2x plus 4y is equal to 0. So it is that simple eventually because of this asymptotes. Asymptotes is joint equation of pair of lines and it is homogeneous. Therefore, if we get rid of that constant, we get joint equation of asymptotes. That theory gives us, given anything, given any one of the three, hyperbola, conjugate hyperbola and asymptotes, you can always find out the remaining two. Okay, so find the equation of one more problem and then we are done. Find the equation of hyperbola which has 3x minus 4y plus 7 is equal to 0 and 4x plus 3y plus 1 is equal to 0 as its asymptotes, and which passes through the origin. Three x minus 4y plus 7 multiplied by 4x plus 3y plus 1 is equal to 0 is joint equation of asymptotes, right? And now your hyperbola equation will differ by constant, we know that. So you can add c to this and it has to again pass through origin. So you need to basically get rid of the constant because x comma y, if you put 0 comma 0, you should get the equation of hyperbola. So you get the final equation as 12x square minus 7xy minus 12y square plus 31x plus 17y is equal to 0 is the equation of hyperbola whose asymptotes are these and it passes through origin. Okay, now I have 45 minutes, good. So let me take one equation, general degree 2. Reduce the equation three x square minus 10xy plus 3y square plus 14x minus 2y plus 3 is equal to 0 and find all the details means eccentricity, latus rectum, center, equation, and length of axis. अजून काय पाहिजे? These are the standard things which you will be asked by giving a general derivative equation. Now, by looking at it, first thing that you can know that is it hyperbola, ellipse, or parabola. So h is 25 minus h square minus ab. No, it's greater than 0, so this is hyperbola. This, so first thing to do is find center. That is why that formula which we have derived is important. Find the center of hyperbola. Second thing, shift origin to the center. And hence you will end up getting something like ax square plus by square plus 2hxy plus constant is equal to 0. Okay. Up to this point you do, then I will tell you how to quickly get the standard form. We use the formula for center. First find out the center. So we have just done the formula for center. HF minus BG upon AB minus H square is your x coordinate, which comes out to be equal to 1. And y coordinate is GH minus AF upon AB minus H square, which comes out to be equal to 2. Okay. If you want to remember the constant term that you have is going to be gx1 plus fy1 plus original c. Original c is this. Now maybe you can call this at c1. Okay. So the constant terms, what is g over here? 7. x1 is 1. F minus 1 into y1 is 2. These are the shift, I mean this is alpha comma beta. X1 is 1, y1 is 2, and your original c is 3. 7 and 3 10 वजा 2 म्हणजे 8. So c1. So you will get the equation, and this is going to be very quick. You are doing it for the first time, therefore you are taking time, but otherwise this is quick. You will get equation 3 capital X square minus 10 capital X capital Y plus 3 capital Y square plus 8 is equal to 0. Okay. Now, from here, 2h upon AB is equal to tan 2 theta. How much 2h is 2h
A minus B denominator.
minus 10 upon 9.
Sir, A minus B.
A minus
A
B.
The
minus B.
denominator A minus B.
0. So they are perpendicular. Correct? Tan 2 theta is infinity. Therefore, 2 theta is equal to, I mean, okay, you can just manipulate that. 2 theta is equal to pi by 2 or minus pi by 2. Therefore, theta is equal to 45. And therefore, tan theta is equal to 1 or minus 1. Now, this is important information. Now, we are not doing the rotation transformation. From here, we are taking divergence, which you need to understand. Okay, what divergence? Now your center of this conic section, this is a conic section whose center is at origin. Okay, center at origin. So any point on that curve x, if I consider r cos theta comma y as r sin theta, which is our general parametric equation of any curve if the center is at origin. If r cos theta comma r sin theta is any point on this curve, then what is r? R is the distance from origin, and what is theta? Now suppose your curve is somewhere like this and you are talking about this point, then you join this is your r and this is your theta. So coordinates of this point is r cos theta comma r sin theta. That is the theory I am using right now, and r is a distance from origin. So r cos theta, r sin theta, if I substitute in this equation, I will do it for you. 3r square theta minus 10 r cos theta into r sin theta plus 3 r square sin square theta plus 8 is equal to 0. And therefore, I will write r square equal to minus 8, okay, minus 8 in the numerator divided by, okay, before that what I can do is, I am okay with tan theta and I am not okay with sin and cos, therefore I divide everything by cos theta, cos square theta. So I get 3r square plus minus 10r tan theta plus 3r square tan square theta is equal to minus 8. And therefore, if I take r square common out, I get minus 8 divided by 3 minus 9. Here also it is r square. 3 minus 10 tan theta plus 3 tan square theta.
सर 8 ला पण cos square theta ने divide.
8 ला cos square ने डिवाइड करायला लागेल, त्यामुळे तो काय होईल, minus 8 upon cos square theta, which is minus 8 sec square theta, which is minus 8 1 plus tan square theta. Is that okay now? That is your r square. If this is your r square and you know tan theta, suppose tan theta is equal to 1, tan theta is equal to 1, then r square is equal to minus 16 upon this is 1, so 10 minus 9 is 1, so minus 16 is that?
minus 1 denominator.
Minus 1 is equal to 16. Therefore, r, that is the distance, that is the largest distance from origin, because now understand this, if we rotate the axis through angle theta, which is 45 degree, we are going to get into standard position. It is a hyperbola. We are going to get into position, and hyperbola is going to be something like this. All the points up, I mean in the standard position, this is the point which we are going to get. R is equal to length of semi major axis, or in case of hyperbola it is transverse axis, is going to be 4. And if we substitute tan theta is equal to minus 1 in this equation, then what will we get? R square is equal to, if tan theta is minus 1, numerator continues to remain minus 16 and denominator becomes minus 1. So it becomes how much?
16.
No, if we substitute -1, tan theta is equal to -1, then we get 16 in the denominator, and hence you get -1. R square is equal to -1. That is correct, because that is the imaginary distance of conjugate hyperbola that we are going to get. Okay, so by doing this method and not really getting into the standard form, you can go back to standard form and report all the answers, but sometimes you might find this interesting and easy, because if you rotate, these two distances are going to be intersection of x-axis and y-axis to the corresponding conic section. If you get r is equal to 4, then this transverse axis, semi-transverse axis is 4, this is 4. If r square is equal to -1, because it is hyperbola and conjugate, we should consider this minus sign, because simultaneously both of them will not exist, and therefore this is 1 and this is 1. So for all practical purposes, your after rotation, after shift of origin, your hyperbola is going to look like x square upon 16 minus y square upon 1 is equal to 0. No, x square upon 4 minus y square upon 1 is equal to 1. This is going to be your standard form of hyperbola after rotation and after shift of origin. So maybe it is up to you whether to follow this route or use your x dash cos theta minus y dash sin theta, rotate it and get back to the standard form. You will arrive at exactly the same thing, and from here you can find out the eccentricity, which is 4 plus 1 upon 4, radical 4 plus 1 upon 4 is equal to root of 5 upon 2. This is your eccentricity. This is A, this is minus A, this is B, this is minus B. So you want lattice length of lattice rectum, you can find out. Now equation of transverse axis. How will you find equation of transverse axis?
सर x square by 16 असं घेणार.
हो सर, x square by 16 पाहिजे.
x square by 16 पाहिजे. थांबा जरा. तर इथे एकच मिनिट. ते बरोबर आहे ना सगळं कॅल्क्युलेशन. 1 टाकलं की होणार आहे -16 आणि इथे 1 टाकलं की होणार आहे बरोबर चाललंय.
सर R4 आहे ना, तर R square 16 होईल.
हो. R4, so hyperbola that is the distance from origin of point A, which is 4. So this is going to be 16. Therefore eccentricity is going to be
सर
ah,
ते R square -16 upon -4 पाहिजे ना.
इथे R square ची value 4 येते.
Yes, sir.
Yes, sir.
अरे हाँ
Yes.
आता बरोबर आहे सगळं, कारण माझ्याकडे इक्वेशन लिहिलेलं आहे तिथे तो 4 लिहिलेला आहे, त्यामुळे वी वर मेकिंग सम मिस्टेक इज हियर. -16 upon -4, therefore r square is equal to 4, and therefore longest distance is 2. So this is 2, this is 2, and therefore eccentricity is correct. Now you find out the equation of transverse axis. X minus y plus 1 is transverse axis is equal to 0, and x plus y minus 3 is equal to 0 is conjugate. Okay, so you have found out everything. Maybe check whether you find this root all right, or you want to go back to standard form and decide. Okay, let me give you one equation And of course, it is going to be of ellipse because we have not solved ellipse yet. So reduce the equation and find exactly all the same things of the equation 11x square plus 4xy plus 14y square minus 4x minus 28y minus 16 is equal to 0. That is the job for remaining 15 minutes. Find everything. Okay. And then constant term that you end up getting is minus 30. So your equation looks like 11 capital X square plus 4 capital XY plus 14 capital Y square minus 30 is equal to 0. Tan to theta comes out to be 4 upon minus 3, implies tan theta is equal to 2 or minus half. Here you have to use tan to theta formula and solve that quadratic to get tan theta. Okay, and now again r square is equal to 31 plus tan square theta upon 11 plus 4 tan theta plus 14 tan square theta. If you substitute tan theta is equal to 2, r square comes out to be equal to 2. And if you substitute tan theta is equal to minus half, r square comes out to be equal to 3. Therefore, major axis, semi-major axis is root 3, semi-minor axis root 2. So you start after rotation, transformation and translation, you get x square upon 3 minus y plus y square upon 2 is equal to 1. This is your standard equation of ellipse. Okay, and therefore you can find out latus rectum, which is LR is equal to 4 upon root 3, eccentricity is equal to 1 upon root 3, but major axis is with this minus half. Therefore, y minus 1 is equal to minus half into x minus 0. That is your major axis, which is x plus 2y minus 2 is equal to 0. And minor axis is because of 2. Therefore, y minus 1 is equal to 2 times x minus 0. And therefore, minor axis is 2x minus y plus 1 is equal to 0. Okay, so more or less, except these coefficients, which are coefficients of this homogeneous part, and this is constant, everything else is same in this. Therefore, this could be quicker than going back to rotation transformation, because there you need to handle cos theta, sin theta and simplify. That is already taken care in this tan theta. We are doing it by dividing by cos square theta, so we are taking care of that, and maybe this is little quick. So you need to spend good time on these examples, maybe create couple of more examples in general form and solve them. That is how you should finish your study of two-dimensional geometry.